Bismillah. Okay, we continue our class, SMS 2310, Mathematical Analysis. And last week we already discussed about double integral. Okay, so we already discussed about the definition. Okay, what is a double integral, and we already discussed some geometrical meaning of double integral, and we already consider some example and exercise how we can evaluate the double integral. Okay, so today we will continue, and today I want to discuss about substitution in double integral. Okay, I think that all of you already heard or familiar with the term substitution. Okay, let us recall. If we consider on your previous course, okay, where we consider integration of single variable function. Okay, let's consider this one. For example, we want to integrate, okay, such a function. Okay, let be 1 plus x squared and then dx. Okay, so this one. Okay. Okay. So, okay, let's evaluate this integral here. Okay. So we have a single integration, and we have a function with one variable here. Okay. So now let us evaluate such an integral. Okay. And another thing. Okay, in my experience, okay, I already encountered some mistake, okay, some common mistake that have been done by the students previously. Okay, for example, we have such a function here, and then we want to integrate that. Okay, we want to integrate. Okay, most of common mistake that I already found in previous, when some student, okay, they did like this one. Okay, for example, if I have 0, 1, okay, so this one I can write this one as 1 plus x squared, and then I will have 1 over 2, okay, dx. Okay, and then the student will do like this. Okay, they will plus 1, okay, then they will be divide by 3 over 2, so they will be something like this, 2 over 3, okay, and then I will have 1 plus x squared, okay, and then this one will be 3 over 2, and then they will over with 2x, okay, something like this one, okay, and then they will calculate this one, okay. So I accounted, okay, so I found, okay, a lot of silly mistake, okay, done by the student, okay, when they evaluate such of integration here. Okay, so actually this one is wrong. Okay, this one is wrong. This one, your calculation here is wrong. Okay, wrong. Okay, because of what? Because you can show that. Okay, you can check. Okay, for example, this part, right? Okay, when you take the derivative. Okay, when you take the derivative of this function. Okay, when you take the derivative of this function, you can check that. Okay, when you take this derivative of this function, okay, so you can check that this one is actually not equal to this one. Okay, it's not equal to this one. Okay, so therefore, such of calculation here is wrong. Okay, when you want to integrate this function. Okay, so this is a common mistake. Okay, common mistake that done by the student. Okay, and I already found some number. Okay, but not many, just some little number. But they do a same mistake. Okay, when they integrate this function. Okay, like this one. Okay, of course this one is wrong. Okay. Okay. So come back to our discussion. So now our problem here, we want to integrate, okay, such a function here. Okay, of course, when you come to the finding the integration here, okay, always you try to evaluate by such well-known formula. Okay, you always start with this one. For example, if I have integration of x squared dx here, okay, so this one is already well-known formula when you want to integrate such a function here. So therefore this one is equals to x power of 3 over 3, and then you just substitute. Okay, for example, if I consider 0, 1, okay, you just substitute x equals to 1 equals to 0 here, right? Okay, and then you get the answer, okay, for such of integration here. Okay, but if you have a sum problem, okay, to find such a formula here, okay, meaning that you maybe you forgot, okay, or you don't know, okay, such a formula, this formula of integration here, meaning that you need to do a second method, okay, second approach. This one is the first approach. First approach meaning that we just use the well-known formula, how we can integrate this function here. But if you cannot find such a formula, or you already forgot how to integrate this one, okay, meaning that you will do a second approach. Second approach here meaning that you need to do a substitution. Okay, you will use the substitution method to solve such of integration. Okay, of course, actually you have 3, right? If I'm not mistaken, in previous course you already discussed about 3 methods here. Okay, first you use a formula, and then the second one you will use the substitution method, and then the third approach you will use the integration by part. Okay, integration by part here meaning that you cannot see how such of integration here can be solved by using substitution. Then the third approach you will use the integration by part. Okay, so this is a 3 approach that you already discussed in the previous course. Okay. Okay, so now come back to our discussion. Okay, so now from here, okay, so now how we can use the substitution method here to solve such of integration here. Okay, of course, since you have something like 1 plus x squared, and then you have a square root here, then you can use such of identity. Okay, you can use such of identity. Okay, which identity? Okay, identity of hyperbolic function. Okay, hyperbola function. Okay, so I will have cosine h squared, for example, u, and then minus, okay, sine h squared u is equals to 1. Okay, so we will use such of identity here. Okay, because of what? Because we have plus here. When we have 1 plus x squared, we will use this identity. And if we have a 1 minus x squared, when you have a 1 minus x squared, then you just use the trigonometry identity. Sine squared, okay, sine squared u plus cos squared u is equals to 1. Okay, if you have minus here, but if you have 1 plus x squared, so you can use this identity. Okay, so now we will use the substitution method here, meaning that from this one, okay, I can just let my x here, I can substitute my x here is equals to, okay, since I will have 1 plus x squared here, so meaning that I will have something like cosine h u is equals to 1 plus sine squared u. Okay, so therefore I can let my x here is equals to sine h u. Okay, sine h u here. Okay. Okay, of course. Okay, now after I let my x here equals to sine h u. Okay, so I will substitute this variable here. So after that I need to find dx du. Okay, dx du. Why I need to find dx du here? Because I need to substitute this one also, right? Okay, because I have a dx. So now when I find the dx over du here, okay, what is the dx over du here? So I will have cosine h u. Okay, cosine h u. So meaning that from here, my dx here is equals to cosine h u, and then I have du. Okay, so this one. Okay. Okay, and then of course, after I find my dx here is equals to cosine h u here, So next I just need to substitute this one, right? Since my x here is equals to sine HU, right? Okay, so I will have this one. Okay, first let's leave this limit of integration here. So now I will have square root of 1 plus, okay, so I will have this one, okay, sine h squared u, okay, and then the x here I will substitute by this one, okay, so I will have cosine HU and du, okay, equals this one. Okay, so now you see, since our function here, okay, now our function here is depend on the variable u, okay, not the variable of x here. So I have a function of depend on variable u, and I will have also this du, right? Okay, with respect to u here. So meaning that my limit of integration here also we need to substitute also. Okay, so this limit of integration with respect to x axis, okay, along x axis. Now I will have the new limit of integration here with respect to u. Okay, so meaning that this limit integration also we need to substitute, we need to change. Okay, so how to find the limit of integration here? Okay, so meaning that if my x here is equals to 0, okay, my x here equals to 0, so meaning that I will have 0 is equals to sine HU here. So therefore I will have my u here is equals to, okay, sine h inverse 0. Okay, when my x here is equals to 1, so meaning that 1 here is equals to sine HU. So therefore my u here is equals to, I take inverse here, so I will have sine h inverse 1. Okay, so this one. So therefore I will have the new limit of integration with respect to u. So this one is equals to u, okay, sine inverse 0, and of course u here is equals to sine h inverse 1. Okay, so this one. Okay, so this part, okay, what do you know of this part here? So since we have this identity, so therefore this one I can write, this one is u equals to, okay, so I will have the new limit here. Okay, of course this one you can calculate, will give you some number, okay, u sine h inverse 1. Okay, okay, always remember, when you do a calculation here, please make sure that your calculator here should be in radian mode. Okay, should be in radian mode, not in degree mode. Okay, so meaning that your calculator here you need to change into radian mode. Okay, so you will have this value and this value. Okay, so what is this one? Okay, by our identity, this one, this part will give me cosine HU. Okay, because of what? 1 plus sine h squared u here is equals to cos h squared u, and then you take the square root here, then you will have only cos u here, and then you have same term here, so therefore I can have cos h squared u. Okay, so this one. Okay, so this part. Okay, okay, so now you only have this part, cosine. Okay, so sorry, this one. Okay, so you have this one. Okay, so this one. Okay, okay, of course this one you can find the formula here. Okay, what is the cosine h squared u here? Okay, and then after you find such a formula of this one, okay, and then you can just calculate, you can evaluate this one. Okay, you can evaluate. If I'm not mistaken, cosine, okay, you can check by yourself. Okay, so this one is equals to 1 plus cosine h 2u over 2. Okay, so okay, you can just check this one. Okay, you can just check this one, and then you just substitute, okay, this one into this one. Okay, and then the final one you get the answer for this integral. Okay, so this integration. Okay. Okay, or actually this cosine HU here, I don't know if this one is already discussed in your previous course or not. Okay, so cos HU here is actually can be write as this one. Okay, cosine HU here is equals to what actually? So this one actually is equals to EU plus e power of minus u, and then I have 2. Okay, so this one. Okay, so therefore if I want to find cosine squared u here, okay, so this one equals to what? So meaning that I will need to square this one. So when I square this one, meaning that I will have e to power of u plus e minus 2u, and then plus 2, and then over with over with 4. Okay, so this one. Okay. So meaning that I can just substitute this one. Okay, I can just substitute this one into this one. Okay, so when I just substitute this one, okay, so meaning that I will have u sine inverse 0. Okay, sine inverse 1. Okay, so now I will have something like 1 over 4. Okay, and then I need to find this one. Okay, just integrate this one. Okay, so this one. Okay, so you have something like exponential here, right? So we have exponential, and then we have 2 here. So straightforward, we can just evaluate, okay, such of integration. Okay, so this one. Okay, so we have some easy term here. Okay, so easy function here. So you can just integrate this one. Okay. Okay, you can just finish this calculation. Okay, since this one is easy for you to calculate. Okay, this one. Okay, but okay, so what is our first conclusion here? Okay, okay, when we discuss, okay, when we look substitution in single integral. Okay, substitution. Okay, substitution in. Okay, I will use a SI here as a single integral. Okay, so for example, if let's consider a general form. Okay, so supposedly I will have f, okay, x and dx. Okay, so this one the limit of course the limit of integration here will be with respect to x-axis, because now I will have, okay, I will have such of integration here with respect to x-axis. Okay. Okay, so by the substitution here, okay, supposedly we have such a problem here. We want to integrate such a function here, okay, with limit of integration here, okay, with respect to x, okay, along x-axis here. Okay, so now how we can use this substitution method? How we can apply? Okay, of course the first thing, okay, you will just let your x here, okay, such a variable of x here is equals to some function which depend on u. Okay, some function depend on u. Okay, u here meaning that we need to substitute our x here, okay, into some function another function depend on one variable. Okay, for example, such a variable here we have u here. So now I will have x equals to gu. Okay, then the next thing, what I need to do? Okay, of course, the second thing I need to find. Okay, I need to find dx. Okay, because we need to substitute this one also, right? Okay, we need to substitute this one. So meaning that how to find my dx here? Dx here meaning that since I have a function depend on u, so I need to take the derivative of x here in terms of u. So I will have, okay, let be g prime u here. Okay, g prime u here. So therefore I will have my dx here dx will be du here. Okay, so this one. Okay, and then of course the third one. Okay, the third one, what I need to do? Okay, since I will have this fx, right? So I have a function depend on x. Okay, so meaning that I need to find such a function here. Okay, such a function here which depend on u. Okay, so meaning that I need to find this one, f. Okay, so x here I need to substitute with gu. Okay, so I need to find this one. Okay, so what is this? Okay, of course it will depend on our function. Okay, so meaning that I need to find this one. So meaning that my x here now, I need to substitute with my substitution here, gu here. Okay, and then of course the number 4. Okay, the number 4. After I find this one, I find this one, and then I need to find the limit of integration here. Okay, so meaning that I need to substitute. Okay, I need to change my limit of integration here with x value here into the limit of integration with u value. Okay, so this one. Okay, always remember, most of students, they forgot to find this one. Okay, after they do the substitution, they still use the same limit of integration here with x value. Okay, of course, this one is not correct. Okay, because you need to find. Okay, because since you already substitute, okay, the whole thing here, meaning that the limit of integration also you need to change into some another limit of integration here with u values. Okay, and then the number 5. After you find the whole thing here, so now you just need to evaluate this integral. Okay, this integral meaning that you just need to substitute. Okay, you just need to substitute the whole thing here. So therefore, this one is equals to what? This one will be equals to, okay, this limit change to this one, u. Okay, so this fx here already changed to this one. Okay, f gu. Okay, and then my dx here already changed to this one. Okay, so this one will be g u d u. Okay, so this is the how, okay, we can do a substitution method. Okay, substitution approach here, where we deal the single integration. Okay, so this one. Okay, so meaning that we have 5 steps here, right? Okay, we have 5 steps. First step, we just let x here is equal to some function here, depend on u, and then the second one, we find dx here. So how we want to find the dx here? By this one. And then number 3, we need to substitute this one. Okay, we need to substitute this one to find, okay, this one. And then number 4, of course, don't forget to find the limit, okay, of integration from x here into u, okay, u values. And then the number 5, the step number 5, you just put into this, you just substitute all the term here. So this one, okay, this one, and then the last one, the x here will be this one. Okay, and then you just can evaluate this integration. Okay, single integration. Okay. Okay, now the second one. Okay, today. Okay, so today we want to discuss about substitution in double integral. Okay, substitution in double integral. Okay, substitution in double integral. Okay, so I will use the short term there. Okay, di. Okay, let be di here meaning that okay, double integral. Okay. Okay. Okay, the idea here. Okay, why we use the substitution approach? Okay, when we deal with the integration here. Okay. If you recall back, okay, in your previous course, okay, in your calculus 2, okay, when you deal with this approach substitution here in the double integral here, meaning that we just want to make our calculation here much easier. Okay, much easier lah. Okay, meaning that if you have a sum problem, okay, like previous side, like the first example I showed you that we have a function that where we want to integrate this function, it's very difficult to use the easy one. Okay, since we don't know the formula, okay, or we already forgot the formula how we can integrate this function, then we will use the second approach. The second approach here meaning that we just substitute to some function, okay, some function, and then we just use some technique, okay, and then after that we found that after we substitute all the terms, okay, if you see the step that I already showed to you, and then the last part here we will have some term that we can evaluate it easily, okay, we will evaluate it easily, okay. So therefore the substitution method here, the objective of the substitution method here, actually we just want to make our calculation here become much easier, okay, much easier here, meaning that we can evaluate, okay, the integral here by using maybe some formula that already well known, okay. Yeah, of course the substitution method here, okay, of course always remember when we come to the integration, okay, either single integral or double integral, of course the very important part is the final answer, okay, because we want to find the value, okay, we want to find the value of this integration, okay. But how it comes to the final values, okay, how it comes to the answer of this integration, okay, so we can use any method, okay, any approach, okay, so that we can have the final answer, okay. Of course the important thing is the final value, okay, the value itself, okay. But this substitution here actually just want to discuss how we can how the method another approach that we can use to evaluate the single integral or the double integral, okay. Always remember that, okay, when you're talking about substitution, meaning that this substitution is just a method, okay, or approach, okay, when you deal to evaluate the single integration or double integration, okay. Of course for the single integration you already discussed in the previous course, okay, but in our course here we want to discuss about how we can use the substitution approach, okay, when we want to evaluate the double integral, okay. Okay, let's start with the definition here. Okay, we already discussed previously the double integral here, meaning that we will integrate such a function here, okay. But now we only have a function with two variables, f, x, y, and of course we will integrate such a function here over R, okay. R here, given that R here is a closed region in the xy plane, okay, of course, and then we will have dA, okay, we will have dA here, okay. Of course this one already discussed all the terms here, okay, and I will show you the geometrical meaning of this one, okay. Okay, so this is a double integral, okay, they already discussed in the last week, okay. Okay, so now, okay, I just write first, okay, how we can calculate, okay, how we can calculate such a double integral here, okay, by applying substitution, okay. Of course, always remember when we come to the substitution here, always start with the substitution itself, okay, or I can say that transformation, okay, substitution or transformation here is just the same thing, okay. So first thing, always start with the transformation, okay, transformation, okay, transformation or substitution here, okay, it's just the same thing, okay. So meaning that, what the meaning of transformation and what the meaning of substitution here, meaning that we will, for example, in single integration, right, okay, so we will change, okay, we will change the variable of x here into some function depend on u, okay, some function depend on u, meaning that we will choose another function with one variable, okay, and then let be x here is equals to this function, okay. But now when we have a double integral, okay, since double integral here we have two variables x and y, so meaning that we will have two substitution, okay, or I can say that we will have two transformation here, okay. The first one I will have x, and then the second one we have y, okay. So meaning that in the double integral here you need to change, okay, you need to substitute two variables here, x and y, okay, because in your function here, you have a function with two variables, x and y. Okay, meaning that when you want to substitute, you need to substitute both of these two variables. Okay, and of course, since we deal with the function with two variables, okay, meaning that my x here I will substitute with function with two variables also. That be u and v. Okay, that be u and v. Okay, and then this y, okay, of course I need to substitute, okay, with the function, okay, with the function also will depend on two variables, u and v. Okay, so I have a such of substitution here, okay, such of transformation here. Okay, okay, so now the difference with the single integration, since your single integration here you only have one variable, so you just said this one variable here is equals to another function will depend on one variable. Okay, previously we already discussed that x here, let the x is equals to gu. Okay, but now when you come to the substitution in double integral, since your function here it depends on two variables, so you meaning that you need to substitute both x and y. But now the difference here, you need to let your x here equals to some function depend on two variables, u and v, and also your y here also should be equals to some function depend on two variables, u and v. So this one. Okay, so this is a substitution, okay, or I can say the transformation, okay, for the double integral. Okay, so this one. Okay, okay, so supposedly we have these two transformation, okay, these two substitution here, x and y. So therefore I can calculate such of double integral here. So this one is equals to what? So this one will give me is equals to, okay, of course I will have a double integral. So we have a double integral here. But now, okay, so now since I have fxy, so meaning that I will have f here. So what is my x here? So meaning that I will need to substitute my x into guv. So I will have guv. And then my y. Y here I need to substitute with this one, huv. So now I have huv. Okay, so this one. Okay, but now, okay, so now I have something like dA here, right? Okay, I have a dA here. So what do you mean of dA here? Since my dA, okay, so since I have my r here, either xy plane, so my dA here can be dy dx or dx dy. Okay, either one. Okay, so now this part, okay, so okay, after I have this one, and then another thing I need to add some term here. Okay, so what is the term here? Okay, so let's write this one. Okay, let's write first. Okay, so this one times with juv. Okay, but now I need to take the modulus. Okay, so I will have a modulus here. Okay, juv, and then I need to take the modulus. Okay, always remember this one is a modulus. Then the inside of the modulus here, okay, absolute value here, I will have juv here. Again, and then of course this one I will have a dA. Okay, dA because double integral. Okay, but now the difference here. Okay, the difference here. So this dA will be dx dy or dy dx because of what? Because I will have a such of r here. Okay, in the xy plane here. Okay, but now the difference here, when I have a such of dA here, so such of dA will be in terms of du dv because we will have the term here in terms of u and v. So meaning that my dA here, I will have either du dv or dv du. Okay, so this one I will have either du dv or dv du. Okay, because you can choose right which order here. Okay, either first order or second order here, right? Okay. Okay, so now this part, since I have a r, okay, so meaning that what the meaning of substitution here? Meaning that substitution here you need to substitute the whole thing here, right? Okay, you need to substitute the whole thing, including the region of integration. Okay, the region of integration. So from this r, I will have the new region of integration of g. Okay, so now I will have the new region of integration. Okay, let be g. Okay, g here meaning that I will transform. Okay, so this G here, the new region of integration that transform from R. Okay, under this transformation. Okay, under this transformation. Okay, so this one. Because of what? Because like we see in the single integration, when we use the substitution here, okay, when you change all the terms, the limit of integration here also you need to change. Okay, from the first limit of integration here, then you need to use the second. You need to change the second limit of integration. Okay, so because of that, we have something like R here. Okay, of course R here will change to G. Okay, because we substitute, right? Okay, we substitute. Okay, so this one. Okay. Okay, let's try to understand. Okay, the term here. Okay, the term here. Okay. So now, okay, so supposedly first we have a transformation here, x and y here. Okay, so we have a substitution. Okay, so now let's try to understand what do you mean of this part. Okay, so what do you mean of this part? Okay, the second part here. Okay, JUV. Okay, JUV. Okay, let's discuss about JUV. Okay, what do you mean of JUV here? So this one is actually, we call it this one as a Jacobian. Okay, Jacobian. Okay, so what do you mean of Jacobian here? Jacobian here meaning that, okay, by the definition, this one JUV is actually is equals to what? Okay, JUV is actually is a determinant. Okay, so I will have a determinant here. Okay, but now what's the element of this determinant? Okay, so first, okay, so I will have JUV. Okay, since I have two variables here, okay, two functions here, this one, right? So I have x and y here. So the first one, I will take dx. Okay, the first one here, I will take dx here, partial derivative with respect to u. Okay, the second element here will be dx dv. Okay, so the second one here will be dy du. Okay, and then this one will be dy dv. Okay, of course this one is just a determinant. Okay, but the important thing is you need to, okay, the definition of Jacobian here was the element of this determinant. Okay, the matrix here. Okay, so this is a definition of a Jacobian. Okay, so meaning that you have partial derivative x here with respect to u, partial derivative of x here with respect to v. Okay, so partial derivative y here with respect to partial derivative u, and then partial derivative of y with respect to dv. Okay, after you find this element, and then you can just calculate the determinant. Okay, so determinant here, I hope that you still remember how to calculate the determinant of this matrix. Okay, you can recall back the subject of linear algebra. Okay, so this is the meaning of this part. Meaning this part is the Jacobian. Okay, this part is the Jacobian. Okay, number 2. Okay, okay, of course the number 3. Okay, the third step. Okay, the first step is a transformation, substitution, and then the second term will be the Jacobian. Okay, this part. Okay, so this is definition of Jacobian. Of course, the third step here. Okay, we need to find this one. Okay, what do you mean of this one here? Meaning that from fxy here. Okay, of course we need to change to such of term. Okay, so since my x here, we substitute into GUV. My y here is HUV. So meaning that I need to just substitute this one, GUV, and then HUV. Okay, so this one will give me the term. Okay, of course, this term will have such of term depend on u and v. Okay, depend on u and v because of what? Because we just substitute, right? So fxy here, we just substitute my x here equals to GUV, and then my y here is equals to HUV here. Okay, so number 3 here. Okay, and then the fourth step. Okay, the fourth step meaning that I need to find g here. Okay, so G here. What do you mean of G here? G here, okay, G here is the region integration. Okay, region of integration. Okay, transform. Okay, region of integration. Okay, or I can say new. Okay, new region of integration. Okay, new region of integration. Transform from R. Okay, from R here. Okay, from R. Okay, of course, from R under the transformation. Okay, under the transformation or under substitution. Okay, under substitution here. Okay, transformation. X equals to, okay, the first transformation, right? X equals to GUV. And then the second one, okay, of course, Y here is equals to UNV. Okay, so this one. G. Okay, what is the meaning of G here? G here meaning that we have a new region of integration. Okay, that transform from R. Okay, the R here is the first our region of integration here under the such of transformation. Okay, of course, the transformation here we already we already mentioned in the first step. Okay, the first step here. Okay. Okay, after we find the whole thing here, okay, then we just substitute. Okay, the last part here, the number 5, we just substitute the whole thing here. Okay, we just substitute the whole thing here. Since we already have this one, we already have calculate this one. Okay, of course, we have a modulus here. And then we already have the new region of integration here, G. Okay, and then we can just evaluate this double integral. Okay, of course, when you consider a substitution here, we are not consider this part. Okay, we are not consider this part because of what? Because this part already substitute into this one. Okay, we already substitute the whole thing here. So meaning that when we want to evaluate this double integral, we just need to evaluate this part. Okay, this part. So this one, therefore this one we call it as a substitution. Okay, we just substitute. Okay, we just substitute. Of course, after you calculate this double integral, okay, you get the final answer. So this final answer actually answer for this double integral. Okay, but how you evaluate this double integral? You substitute into this one, and also you calculate the second part here. Okay, and then you get the final answer. Okay, so this one. So this is how we did substitution in double integral. Okay, so we have same like the substitution in single integral. We have 5 steps. Okay, when we want to use substitution approach. Okay, in the single integral. Okay, same with the substitution in double integral here. We also have a 5 step. Okay, we have a 5 step. Okay, so if you see that it seems like similar, okay, to the substitution in single integration. Okay, but now the different here. Okay, of course you have a different transformation, different substitution, and also you have a Jacobian, the second part. And then the third part here you need to substitute. Okay, the number 4 here you need to find this region, new region of integration. And then the number 5 just substitute this one. Okay, so this one. Okay, let's consider example. Okay, let's consider example number 1. Okay, using the transformation, okay, using the transformation, okay, let be using the transformation, u is equals to x minus y, and v is equals to 2x plus y. Okay, using the transformation. Okay, so this I have the transformation here. Okay, then evaluate. Okay, then evaluate. Okay, this double integral. Here 2x squared minus xy, okay, minus y squared. Okay, now I have dA. Okay, so my R here, okay, for the region R, okay, for the region R, here R, in the first quadrant, bounded, okay, bounded by y is equals to, okay, minus 2x plus 4, okay, y is equals to minus 2x plus 7, y is equals to x minus 2, okay, and y is equals to x plus 1. Okay, so okay, first example. Okay, of course, in our course, we consider that the transformation here is already given. Okay, the transformation here is already given. Okay, of course, in the real problem, okay, you need to find yourself the transformation. Okay, but of course, in our course here, just to discuss about the idea. Okay, the idea of substitution in double integral. Okay, so we just give. Okay, we already given that the transformation here. Okay, the transformation here. Okay. Okay, of course, the important thing in our course here, you need to know how to use the search of substitution in double integral here. Okay, to evaluate. Okay, for given this double integral. Okay. Okay, let me consider this one as a first example. Okay, let's consider this one as a first example. Okay, so let's try to solve this question. Try to solve this example. Okay. Okay. Where I want to write? Where I want to write? Okay, maybe. Okay, maybe I will. Okay, I will this one first. Okay. Okay, so this one. Okay, so this one. Okay. So the first thing, always start write the definition first. Okay, write the definition. Okay, when deal with the substitution here, Okay, when we deal with the substitution here, okay, how to calculate, how to evaluate this double integral. Okay, how to evaluate this double integral. Okay, okay, so I just want to, okay, so I just do this one. Okay, the first thing, always start with the what I can say, not the definition, sorry, I'm sorry, the correct word should be formula. Okay, maybe formula. Okay, so how we can evaluate this double integral here? Okay, when we use the substitution double integral, so this one, my r, okay, of course, I will have my fxy, okay, dA. So this one is equals to what? Okay, so this one will give me the double integral. Okay, so now my r here I need to change into g. Okay, and then I will have f. So this one will be what? Okay, so this one will be some function. Okay, GUV, okay, HUV, okay, and then I will take the absolute value. Okay, I will take the absolute value, GUV, and then I will have DE. Okay, so this is the formula. Okay, the formula how we can evaluate such a double integral here. Okay, under some transformation. Okay, or under some substitution. Okay, so this one. Okay, so first, the first thing, of course, we need to find. Okay, we need to find our transformation. Okay, our substitution. Okay, I just use the word transformation. Okay, since the same thing. Okay, we need to find the transformation. Okay. So what is our transformation here? Meaning that we need to substitute our x and y. Okay, we need to substitute our x and y here. Okay, of course, my x is into some function depend on u and v, and then my y here should be some function depend on u and v. Okay, so this one. Okay, so meaning that I need to find this function here. What is my function here? And then what is my function here? Okay. Okay, already given in this question, this example, that my u here is equals to what? Is equals to u here is equals to okay, u here is equals to x minus y, and then this one, my v here is equals to 2x plus y. Okay, 2x plus y. Okay, so this one. Okay, so this one. Okay. Okay, so now since my transformation here not in terms of x and y, right? Okay, because I have u is equals to x minus y, and then v here is equals to 2x plus y. So meaning that I need to find what is my x and what is my y here. Of course, my x here should be in terms of function depend on u and v. So this one also is some function depend on u and v. Okay, so meaning that I need to find what is my x and my y here from this transformation here. Okay, so from here, I can say that for example, my x here is equals to u plus y. Okay, so I will substitute this one. So I will have my v here is equals to 2u plus y and then plus y. So therefore I will have my v here is equals to 2u, and then plus 2y plus y. So I will have 2u plus 3y. So therefore I will have my y here is equals to v minus 2u over 3. Okay, v minus 2u over 3. So this one. Okay, so therefore my y here, okay, from this one, I will have v minus 2u over 3. Okay, so this one. Okay, because I need to find my y here in terms of function depend on u and v. So I will have u and v here. Okay. Okay, so after I have my y here is equals to v minus 2u over 3. So therefore I can find my x here. Okay, because I can find my x here, right? So what will be my x here? So since I have x here is equals to u plus y, x here is equals to u plus y. So what is my y? My y here will be this one. So I will have u, okay, u plus y. V minus 2u over 3. Okay, so I will have 3u minus 2u, so I will have u. Okay, so therefore 3u minus 2u, so I will have u plus v over 3. Okay, so therefore this one, so I will have u plus v over 3. Okay, so now I already found the transformation here. So my x here is equals to u plus v over 3. My y here is equals to v minus 2u over 3. Okay, so this one. Okay. Okay, always remember when you want to find the transformation here, always remember, meaning that you will need to find your x here in terms of function depend on u and v, and also my y here should be some function depend u and v. Okay, the second thing. Okay, what we need to calculate the second thing. Okay, the second thing here meaning that I need to calculate this one, this Jacobian. Okay, JUV. Okay, how to find the JUV here? Okay, so by the definition, JUV here is equals to 1. So this one is just a determinant, right? Okay, you need to find determinant. Okay, so the first one will be dx, partial derivative of dx du. What is my dx du? Dx du here will be 1 over 3. And then what is my dx dv? Dx dv here will be 1 over 3. So this one dy du. What is my dy du here? My dy du here will be negative minus 2 over 3. What is my dy dv? Dy dv here will be 1 over 3. Okay, so this one. Okay, dx du, dx dv, dy du, dy dv. Okay, so this one will give me 1 over 3 times 1 over 3 will be 1 over 9. And then I need to take the minus this multiplication here. So I will have minus 2 over 3 and then times 1 over 3. Okay, so therefore I will have 1 over 9. Okay, so this one will be 2 over 9. So I will have minus here, meaning that 1 over 9 plus 2 over 9 will give me 3 over 9. 3 over 9 actually is equals to 1 over 3. Okay, 1 over 3. Okay, so I will have this value, meaning that the Jacobian, okay, the Jacobian of my JUV here is equals to 1 over 3. Okay, so this is the second step. Okay, we calculate here. Okay. Okay, the third step. Okay, the third step meaning that we need to find this one, right? Okay, we need to find this term here. Okay, we need to find this term. Okay, maybe I can just this one. So number 3 here. So since I have my fxy, what is my fxy here? Okay, so what is my fxy? So my fxy here is equals to 2x squared minus xy minus y squared. Okay, so this one. Okay. Of course, now I need to find my f. Okay, what is my x here? My x here, I need to substitute this one, right? Okay, so I have u plus v over 3. Now what is my y here? My y here will be this one, v minus 2u over 3. So this one. Okay, so I need to find this one. Since we use the substitution, right? We use the transformation here, meaning that I need to substitute my x here to this transformation, and my y here to this transformation. V minus 2u equals to 3. So this one we can calculate this one. So I will have 2, okay, u plus v, and then over 3 squared, okay, and then minus, okay, what is my x here? My x here will be this one, okay, u plus v over 3, and then what is my y? My y here will be v minus 2u, okay, over 3, okay, and then minus, okay, of course this one, v minus 2u, okay, over 3 and square, okay, so this one. Okay, so what's the value here? Okay, so since I have 3, okay, I can just put outside. So this one I will have 1, okay, 1 over 9, okay, 1 over 9. Okay, so now I will have 2. Okay, so this one is squared, right? Okay, so this one is squared, so I have u squared plus v squared plus 2uv. Okay, and then this one, okay, so I have what is one? Okay, so I have minus, okay, minus, so I will have uv minus 2u squared plus v squared minus 2uv. Okay, and then this one minus v squared plus 4u squared, okay, and then minus 4uv. Okay, so this one. Is it correct or not? U squared plus v squared plus 2uv, and then I have a uv minus 2u squared plus v squared, and then minus 2uv, and then I will have minus v squared plus 4u squared minus 4uv. Okay, so in the end you will have what? Okay, I will have, okay, so this one I can say that this one is equals to 2u squared plus 2v squared plus 4uv. Okay, so this one minus, okay, minus, so I will have uv minus 2uv should be minus uv, so I will have plus uv here. Okay, so I will have plus uv, and then plus 2u squared minus v squared, and then I will have minus v squared minus 4u squared plus 4uv. Okay, so this one. Okay, so okay, so plus 2v squared minus v squared minus v squared. Okay, so this one I can cancel this one. Okay, so I will have 2u squared plus 2u squared minus, okay, so this one I will cancel. Okay, now I have a 4uv plus uv. Okay, 4uv plus uv plus 4uv. 4uv plus uv plus 4uv will be 9uv. Right, 9uv. Okay, 9uv over 1 over 9. Okay, in the end, so in the end you only have uv. Okay, in the end you only have uv only. Okay, so this one is equals to uv. Okay, you can check. Okay, this one is equals to uv. Okay, so this one equals to uv. Okay, so we already comes to the third step. Okay, so the fourth step. Okay, the fourth step is is very difficult part. Okay, difficult step here. What is the fourth step here? The fourth step here meaning that we need to find the new region of integration here, G. Okay, we need to find the new region of integration G here. Okay, so number 4. Okay, okay, since I have GUV here is equals to 1 over 3, okay, I can just substitute this one first. Okay, so I have 1 over 3, and of course because this one is the absolute value, right? Okay, always remember we need to take the absolute value here. This value can be negative. Okay, of course when this value is negative, meaning that when you take the absolute value it's always positive. Okay, so this one, since we have a positive number, so let me this one. Okay, 1/3. And of course, I already found this part. Okay, I already found this one is equals to UV. So therefore, I only have UV. Okay, so I only have UV here. Okay, so this one. Okay, so the fourth step. Okay, so now we need to find the G here. Okay, the fourth step. Okay, we need to find the G. Okay, so this will be the difficult part here. Okay, the difficult part here. Okay, so now let's find G here. Okay, let's discuss how to find the G here. Okay, it's already given that our R here. Okay, our R here is in the first quadrant that bounded by this 4 line. Okay, so first of all, okay, let's sketch our R first. Okay, what is our R? Okay, so of course our R here is a region. It's a closed region in the XY plane. So now I will have Y and X here. Okay, Y and X here. Okay, first line. Okay, let's sketch on line here. Okay, let's sketch on line here. Okay, the first one, Y is equals to minus 2x plus 4. Okay, so meaning that we have this line. When X equals to 0, Y equals to 4. Okay, when X equals to 0, okay, what do you mean of X equals to 0? X equals to 0 meaning that my X here equals to 2, so I will have this one, X equals to 2. So I will have this straight point. Okay, so this one. Okay, so this one. So this one. And then the second line will be Y is equals to minus 2, 7. Okay, so minus 2x plus 7. Okay, this one will be Y is equals to minus 2x plus 4. Okay, and then the second one. Okay, I will have 7. Okay, so I will have a 7, and then I will have somewhere in the 7 over 2. Okay, somewhere in 7 over 2. 7 over 2 should be 3.5. Okay, 7 over 2 should be somewhere here. So this one, I will have this straight line here. Okay, so this one will be Y is equals to minus 2x plus 7. Okay, so this one. Okay, and then I will have Y is equals to X. Y is equals to X minus 2. Y is equals to X minus 2. So I will have minus 2. So I will have this one. Okay, Y is equals to X minus 2. And then Y is equals to X plus 1. Okay, so I will have somewhere here 1. Okay, so this one, I will have this one. Okay, Y is equals to X plus 1. Okay, and of course our R here is a close. Okay, and then bounded by these 4 lines. So where is our R here? Okay, so our R here will be this part. So this will be our R. Okay, close region R here. Okay, so now we have our R. Okay, we have our R here. Okay, but of course for the fourth step we need to find G. What is the meaning G here? G here is a region. Okay, it's a region of integration. Okay, of course region of integration here will be in the UV plane. Okay, UV plane, because of what? Because we have a UV variable here, right? Okay, so now we need to find our G here in the UV plane. Okay, we need to find the region here, G, in the UV plane here. So meaning that my R here, okay, we need to transform into G. Okay, where G here is a closed region in the UV plane. Okay, of course, G here will be our new region of integration under this transformation. Okay, under this transformation. Okay. Okay, so now the fourth step here, we need to find our G here. Okay, how we can find our G here? Okay. Okay, since our R here, Okay, since our R here is bounded by this 4 line, okay, so meaning that we need to transform. Okay, we need to transform all line here. Okay, all boundary here into UV plane here. Okay, meaning that we have 4, right? Okay, we have 4. Meaning that we have first here, okay, second line here, and then third line here, and then we have a fourth line here. Okay, okay, let's transform. Okay, let's transform our first line here into UV plane. Okay, let's transform this line. Okay, okay, how we can transform this line here into UV plane here? Meaning that since our x here is equals to since we have this transformation, okay, so we have u plus v equals to over 3, and then we have this one. So meaning that, okay, y, okay, so I consider this one first, y x plus 1. Okay, so this one, how I can transform this line into UV plane here? Okay, so meaning that my y here is equals to v minus 2u over 3 is equals to x. Where is my x here? My x here will be u plus v over 3 and then plus 1. Okay, so this one. Okay, because of what? Because we need to transform here. Okay, this line here under this transformation. Okay, we will use the same substitution here. We use the same transformation here. Because of that, in the first line here, I will have something like y is equals to x plus 1. So my y here, since my y is equals to v minus 2u over 3, and then this one u plus v over 3. So x is u plus v over 3 plus 1. Okay. Okay, what will be my the final answer here? So I will have, okay, so this 3, so meaning that I can have something like plus 3, okay, plus 3 here, okay, because we can times with 3 here, and then I will cancel this one, so since this one, okay, so now I will have v minus 2u is equals to u plus v plus 3. Okay, so since I have positive v here, so I can cancel this one. So the last one I will have what? Minus 2u, u, so I have 3u, sorry, I have 3u equals to minus 3. So meaning that I will have u here, okay, sorry, so I will have 3u, okay, and then I have minus 3. So 3u equals to minus 3. So meaning that I will have u here equals to minus 1. Okay, so now I will have u is equals to minus 1. Okay, from our calculation here, we substitute our transformation. Okay, u equals to minus 1. Okay, what the meaning of u is equals to minus 1? Meaning u equals to minus 1, I will have, okay, since this one is u exists, this one is v exists, right? So now I will have this part. Okay, so now I will have u is equals to 1. So meaning that this line, okay, under this transformation, it will change, it will transform into u equals to 1 in the UV plane. Okay, so this is the first one. Okay, okay, the second one. Okay, let's transform the second line here. Okay, y is equals to x minus 2. Okay, y is equals to x minus 2. So now I will have y is equals to x minus 2. Okay, what is my y here? My y here will be v minus 2u over 3. And then what is my x here? My x here will be u plus v over 3 and then minus 2. Okay. Okay, so therefore this one, I can write this one as minus 6. Okay, so I will have a minus 6 and then over 3. So I can cancel this one, right? And then since I have positive v, so I can cancel this one. So now I only have something like what? I will have something like 3u. Okay, 3u. And then it's equals to 6. Therefore, from here, I will have u here is equals to 2. Okay, u is equals to 2. Okay, so what meaning u equals to 2 here? U equals to 2 here, meaning that I will have somewhere here u equals to 2. So this one will be, okay, u is equals to 2. So meaning that the second line here, y equals to x minus 2, under this transformation, okay, it transforms into u is equals to 2 in the UV plane. Okay, so next I need to transform this one, this line. Okay, I need to transform this line. Okay, why I need to consider such of line here? Because this line is a boundary of my R. Okay, so meaning that I need to transform all boundary of R here into UV plane. Okay, I already transformed the first line. I already transformed the second line. Now I need to transform the third line. Okay, so how I can transform the third line here? So meaning that, okay, I need to calculate this one. Okay, number 3 here. Okay, so now I will have y is equals to minus 2x plus 7. Okay, y is equals to minus 2x plus 7. Okay, what is my y here? My y here will be v minus 2u over 3. Okay, v minus 2u over 3. And then what is my 2x here? Minus 2x here will be minus 2u plus v over 3 and then plus 7. Okay, of course it's my 3 here. Okay, I can just let this one is equals to plus 21 over 3. So I can cancel this 3. Okay, and then I will have v minus 2u. Okay, and then minus 2u minus 2v plus 21. Okay, so since I have minus 2u here, so I can cancel. And then I will have v minus 2v plus 21. Okay, what the meaning of v is equals to minus 2v plus 21. So I will have something like 3v. Okay, 3v here. So I will have 3v is equals to okay, so I will have 3v here is equals to 21. Okay, so meaning that from here I will have my v here is equals to 7. Okay, my v here is equals to 7. Okay, what the meaning of v here is equals to 7? So I will have 7 here and then I will have this part. Okay, v here is equals to 7. So meaning that the third line here, okay, y is equals to minus 2x plus 7. Under this transformation, it transfer into v equals to 7 in the UV plane. Okay, the UV plane here. So I have v equals to 7. Okay, and then the last one also, of course, you need to transform this boundary here. Okay, y is equals to 2x plus 4. Okay, minus 2x plus 4. Okay, how to transform this one? So meaning that I will have minus 2x plus 4. Okay, minus 2x plus 4. So I will have v minus 2u over 3 is equals to minus 2 ku plus v over 3 and then plus plus 4. Okay, plus 4. But now I need to times with 3. So this one will be 12. Okay, so I can cancel this one. So now I have v minus 2u minus 2u minus 2v plus 12. Okay, so minus 2u here I will cancel. Now I only have v is equals to minus 2v plus 12. Okay, so meaning that I will have something like 3v. Okay, so I will have 3v is equals to 12. Okay, meaning that from here my v here is equals to 4. Okay, so where is the v equals to 4? So v equals to 4 is somewhere here. So now I will have a straight line. Okay, v is equals to 4. Okay, you see? Okay, from boundary of R here. Okay, so we have 4 R. Okay, so we have 4 line here. Okay, under this transformation. Okay, under this transformation, we transfer all of it. Okay, into UV plane. Okay, into UV plane. So meaning that this line is transformed into u equals to 1. This line is transformed into u is equals to 2. Okay, this line, okay, it transformed into v equals to 7. This line is transformed into v equals to 4. Okay, and then you see, okay, such of r here in between y is equals to x plus y and y is equals to x minus 2, right? Okay, in between these two lines here, right? Okay, since this line is y equals to 1, u equals to minus 1, u equals to minus 1, and this one u equals to 2. Okay, so in between meaning that it will between u equals to minus 1 and u equals to 2. And then you can see this r also is between these two lines. Okay, this line and also this line. So this line is transformed into v equals to 4. This line is transformed equals to v equals to 7. Since the r here in between these two lines is also between these two lines here. So meaning that my g here will be this rectangle. So I will have this one. Okay. So now I will have the new region of integration here in the UV plane. Okay, in the UV plane. So I have G here. So we will have a simple region of integration here since we only have a rectangle here. Okay, we have only rectangle. You see, this region of integration is something like complicated, right? Okay, something like complicated here. But under this transformation, we transform our r here into G. Okay, another new region of integration in the UV plane. Okay, and then you see our r here is transformed into G, and then our G here we only have the rectangle here. Okay, some simple region of integration of G. Okay, of course from this G, okay, then you can see okay, so how we can find the limit of integration of G here since we have U and V. Okay, of course I can describe my G here. Okay, I can describe my G here as a point of U and V. Okay, such that my U here, my U here should be in between which value? So since my U here between minus 1 and 2, right? Okay, so I have minus 1 and 2. Okay, and then my V. What is my V here? My V here meaning that I need to take from this one to this one, right? From the lowest value to the highest value here. So what is this line here? So this line here will give me V equals to 4. This one will give me V equals to 7. Meaning that my V here is between 4 and 7. Okay, because a rectangle. Okay, rectangle is easy to integrate. Okay, so my U here between minus 1 and 2. My V here between 4 and 7. Therefore, this one, we have the new limit of integration. Okay, so first I will consider U here equals to minus 1, U here equals to 2, and then I will have the second one, V here is equals to 4, V here equals to 7, then I will have 1 over 3 UV. Okay, of course the first limit of integration here with respect to dV, and then the second one here will limit to du. Okay, so now we only have a simple integration here. Okay, I will have a simple integration. Okay, so what is this one? So first with respect to V meaning that I will have U equals to minus 1, U equals to 2, 1 over 3 U, V squared over 2. Okay, and then V here is equals to 7, V here is equals to 4, and then I will have du. Okay, I will have du. So now I will have something like U equals to minus 1, U equals to 2, 1 over 3 U. Okay, so therefore this one I will have 49. Okay, I think I will have a 49 over 2 and then minus 16. Okay, minus 16 over 2. Okay, minus 16 over 2. And then I have du. So what is this number here? So this number will give me what? Okay, you can calculate this one. Okay, and then this u, right? Okay, u here I will have 1 over 3. Okay, so of course this one is just a number, 49 over 2. Okay, 16 over 2, and then I will have u squared over 2 u is equals to 2, u equals to minus 1. Okay, so this number will give me what? Okay, so this number will give me 1 over 3, 49 over 2, 16 over 2. Okay, you just take this one, so I will have 4 over 2. Okay, 4 over 2 and then minus 1 over 2. Okay, so this one will be the final answer. Okay, so this one. Okay, you can check. Okay, on the way you can check my calculation here. Okay, if no problem. Okay, if no some miscalculation here, the final answer will be this one. Okay, so you see, right? Okay, how the substitution works in this double integral. Okay, meaning that we have such a function that integrate in some closed region in the xy plane, and then you see it's very complicated. Okay, very difficult to solve this double integral, but using this substitution, okay, using this transformation and this method, so finally you will come to a simple integration here. Okay, simple double integration here. Okay, of course we need to substitute the whole thing here. Okay, this term we need to substitute. Okay, this term we need to substitute. Of course, the limit of integration here also we need to change. Okay, in terms of u and v. Okay, so after that, after come to this one, we already have the just easy calculation here, and then we get the final answer here. Okay, so this one. Okay, we stop we stop here. Okay, for our discussion, but I will give you one example. Okay, I will give you one home task. Okay, I will give you one home task. Let me this one is your additional example. Okay, additional example. Of course, you need to understand how we can apply this substitution. Okay, in the double integral. Okay, the first thing you need to understand how it works. Okay, from this first example, and then for the second example here. Okay, let me this one is your home task. You can try by yourself. Okay, follow from this first calculation. Okay, from the first example, and then try to understand by yourself. Okay, how we can use the substitution method in the double integral. Okay, let me this one is your home task. Okay, no need to submit, but if you want me to check, I can check for you. Okay, so let me home task. Okay, using the transformation. Using the transformation. Okay, u is equals to 3x plus 2y. Okay, and v is equals to x plus 4y. Okay, let me explain. Okay, so we will have this transformation. Then evaluate. Okay, so then evaluate. Okay, this one. Okay, this one. Okay, plus 14 xy, and then plus 8y squared d e. Okay, where my r here? R is the region in the first quadrant. Okay, the first quadrant. In the first quadrant, bounded. Okay, in the first quadrant, bounded by Okay, y is equals to minus 2x plus 4. Oh, sorry. Bounded by, okay, this one. Okay, minus 3 over 2x plus 1. Y is equals to minus 3 over 2x plus 3. Okay, y is equals to minus 1 over x, and y is equals to minus 4x plus 1. Okay, nampak? Can you see it? Okay. Okay, let me, this one is your second example. Okay, you can try yourself first. Okay, you can try yourself first. Okay, you can follow my step. Previously, I show you in the first example. Okay, of course, the difficult part will be the number 4 step. Okay, where you need to find this G. Okay, you need to find this G under this transformation. Okay, after that you can just calculate this double integral. Okay. Okay, you can try by yourself. Okay, no need to submit, but if you want me to check, you can just send your answer, okay, your solution here through my through Telegram to my number. Okay, I will check all your calculation here. Okay. 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 So we stop, and then we will continue. We'll continue next time. Okay. Thank you very much.